I'm here to help you go through the practice problems for lesson 5. And so I've got them all worked out on the board. Here's the thing, because of time, I'm not able to work through all of the problems. So I'll work through the first one and I'll tell you how to do it, and then I'll go through the answers that I got for the others. I have them all written out on the board, so if at any time you want to pause this video to look at my work, that is totally okay. I mean, not like I would know anyways, so that's good. And hopefully you'll understand this. It's not too tricky. It's just a little bit of math and knowing the process, but hopefully I'll be able to explain it to you so that you can understand. So here we go. Okay, so we'll start with the steps that it takes to solve this. And so we have 8 steps, and it is step 1, set up the trihybrid test cross. Step 2, determine the allele arrangement. Step 3, determine the gene order. Step 4, rewrite the trihybrid. Step 5, determine the map distance between gene 1 and the middle gene. Step 6, determine the map distance between the middle and the third gene. Step 7 is to generate the linkage map, and step 8 is to calculate interference. So let's go through this. It's going to be fun. So for number 1, it says in the corn, alleles capital C, which is dominant, and lowercase c, which is recessive, result in the colored versus the colorless. So colored is dominant, colorless is recessive. The capital WX, which is dominant, and lowercase wx, which is recessive, result in non-waxy versus waxy. So non-waxy is dominant, waxy is recessive. And capital SH, which is dominant, and lower sh, which is recessive, resulting in plump versus shrunken. So plump is dominant and shrunken is recessive. When plants grown from seeds heterozygous for each of these pairs of alleles were test crossed with plants from colorless, waxy, shrunken seeds, the progeny had the following phenotypes. Okay, so I have the progeny written out here. And so they have crossed a heterozygous with a complete recessive. And so I have that written out here. And so we're going to do steps 1 and 2, which is to set up the trihybrid test cross and to determine the allele arrangement. So we have parent 1 that is heterozygous and parent 2, which is recessive. And so when you cross those, to figure out what the allele arrangement is, what you're going to want to do is you're going to want to look at the most common prodigy. That's the word I was looking for. So the most common prodigy. So here I have that underlined in orange. We have 2,349 of colorless, waxy, plump, and 2,260 of colored, non-waxy, and shrunken. And so that is what the allele arrangement is going to be. So you can put that either on the top or the bottom, top, whichever way you want to do it. So it'll be colorless, waxy, plump. So I've got lowercase c, lowercase wx, capital sh on the top, and then colored, non-waxy, plump, capital C, capital WX, lowercase sh. Just to kind of give you like a little tipper, I guess, when you have the lowercase c, lowercase wx, capital sh, every single time on the bottom it's going to be the exact opposite. So you have a lowercase c, you have a capital C. Does that make sense? Anyways, so that's how you discover the allele arrangement. Remember, it's with the most common prodigy. All right, and so next we're going to want to do step 3 and step 4, which is determine the gene order and rewrite the trihybrid. So what we're going to do is we're going to write out 3 different ways that this order could go. And the way I know it's only 3 different ways is there's only 3 different options for the middle option, and that's what we are looking for. I mean, the ones on either side doesn't really matter as long as you have the middle one correct. So we have either WX in the middle, C in the middle, or SH in the middle. And so what you're going to want to do for this one is look at the least common prodigy. That's what we call the double crossover. And so here we have numbers 20 and 15. So we have colorless, waxy, shrunken, and colored, non-waxy, and plump. So what we are going to want to do is look at these middle. When we flip the middle, we want, if we were to flip it, we'd want those to read the double crossover phenotypes. So let's look at this one. If we were to switch it, so we have capital WX on the top and lower WX on the bottom, we'd have colorless, non-waxy, and plump. Let's see, colorless, no. So that's not going to work. So we're going to move on to the next one. We're going to switch our C's. We have capital C on the top and lowercase c on the bottom. So we'll have plump, colored, and waxy. So we have plump, colored, non-waxy. So that's not going to work. So let's move on to the third one. Hopefully this one is the one that works, or else we're in trouble. But let's just double check. So we'll switch the SH. We have capital SH on the bottom, lower SH on the top. So we'll have waxy, shrunken, and colorless. So colorless, waxy, shrunken. Perfect, right there. Now let's look at the bottom. We'll have non-waxy, plump, and colored. Non-waxy, plump, and colored. Perfect. So this is our gene order, and so we have it rewritten here. The lowercase wx, capital SH, lowercase c, capital WX, lowercase sh, capital C. Like I said before, it doesn't matter what's on either side as long as you have that SH in the middle. It doesn't matter if the C is on the right or the left, or if the capitals are I guess if these two are switched from bottom to top. Doesn't matter as long as you have that SH in the middle. That's all that matters, okay? So we just completed steps 3 and 4. Now let's go on to steps 5 through 7, which is to determine the map distance between the first and the middle gene and the middle gene and the third gene, and then to map our linkage map. So here, what I've done is I've added up all of the progenies, and our total here is 6,708. And then here is our allele order. Here we have WX, SH, and C. Okay, so what we're going to do is we're first going to calculate the distance between the WX and the SH on the gene is what we're calculating essentially. And so we're first going to use the double crossover numbers. And so those are our least numbers, 20 and 15. So we'll have those there. And then what we're going to do to get the other two numbers is we're going to take the first one, let me get a different color so you can see this better. We're going to take the first one, WX, and we're going to take that, and then we're also going to grab the lowercase sh and the capital C, and that's the number that we're going to get. So we're going to get the number for waxy, shrunken, and colored. So we'll go over here to, let's see, waxy, shrunken, and colored, that's 951. So we got that here. I write that down just to remind me. So we've got 951 here. All right, so we've got that. Now we're going to do it again, but from the bottom to top. So we'll take the bottom, WX, the top, SH, and C. So we've got non-waxy, plump, and colorless. So non-waxy, plump, and colorless, that's 974. So we've got that written out. So then what we're going to do is we're going to add those numbers together and then divide them by the total number of progeny and then times that by 100. So we've got 15, that's funny. 15 plus 20 plus 974 plus 951 all over 6,708. You times that by 100 and you get 29.2 MUs. That's the unit that we use. And so that's the difference, that's the distance between WX and SH. All right, so now let's calculate the distance between SH and C. So what we're going to do is the same thing, but in reverse. So we're going to grab the C up here, and then come down and grab the SH and WX. So we're looking for non-waxy, shrunken, and colorless. So let's see, non-waxy, shrunken, and colorless. So we got 84 of those, so we got that written there. And then we're going to do that one more time, but the opposite. So we're going to grab this bottom C, and then come up and grab those SH and WX. So we'll have waxy, plump, and colored. So we have waxy, plump, and colored there. That's 99. So again, we'll put that with our equation. We'll add those together with the double crossovers. You don't want to forget those numbers. So you'll have 15 plus 20 plus 99 plus 84. And you'll divide that by 6,708, times that by 100. And you have 3.2 MUs. The distance, and that's the difference between SH and C. Once you have those numbers, it's really easy. You just put those into your map. So you have the WX, the distance between that and SH is 29.2 MUs, and the distance between SH and C is 3.2 MUs. And that is what the linkage map looks like. And then, now, okay, so we've just done steps 5 through 7, and now we're going to do step 8. And this is to calculate the interference. So what we're going to do is we're going to take those distances that we've just calculated, and we're going to put them over 100 and multiply them together. So we're going to do 29.23 over 100, and then times that by 3.2 over 100, where you get 0.009344. Now you don't want to round your numbers just yet, because each number is so important until the end, and you might end up getting a little bit of a different number So don't round yet. So then what you're going to do is you're going to take that number, 0.009344, and times that by the total, 6,708, and you'll end up getting 62.68. Now, our equation for getting the interference is 1 minus c. To get c, you're going to take the double crossover numbers over this number that you just got. So we'll take 20 plus 15. Those are two double crossover numbers. And then over 62.68, which is what we just got over here. And then we'll subtract that from 1, and we'll end up getting 0.44 or 44% rate of interference. All right? So that's how you work it out. And so what I'm going to do is I'm going to go through and tell you the answers that I got for the others. Again, I have it all worked out already, the math and everything. So if you have any questions of how I got there, feel free to pause the video and look through my math and see how I got that. All right? So let's move on to number 2 here on this side. So for our allele arrangement, we got capital STN on top and lowercase stn on the bottom. And then for the allele or the gene order, we got NST. I guess I should circle that. The order should be NST. And so really, like I said, it doesn't matter what's on the sides as long as you have S in the middle, then you got it right, all right? Okay. So then to calculate for the distance between N and S, we have 16.3 MUs. And the distance between S and T, we have 6.4 MUs. So here's our linkage map right here, and 16.3 S, 6.4 T. And then here we've calculated our interference, and you end up getting 0.51 or 51% interference. For 3, we have our allele arrangement here, and it's CT, Y plus V plus, and the plus just indicates it's a wild type. And on the bottom we have CT plus YV. And then our order that we end up getting is V plus, CT, Y plus, and make sure that CT is in the middle, basically. All right, and so then once you calculated it out, the distance between Y and CT is 20, and between CT and V, we have 13 MUs. Make sure you don't forget the MUs. And then you put that in your linkage map, and we got that here. And then you calculate the interference, and you get 0.615 or 61.5%. Now for 4 over here, sometimes they don't list what is represented by the dominant or recessive, and so especially in this problem, make sure that you write out what you use to represent the dominant and recessive traits, just so that the teacher knows what's going on and it's a little less confusing. So I've got that right now here, and so our allele arrangement, we end up with Y plus B plus C, and then YB and C plus. And then for our gene order, we end up having Y plus C, B plus, or C in the middle. All right, and then to calculate the distance between Y and C, I got 12.7 MUs, and then the distance between C and B, got 7.1 MUs. And so then there is my linkage map right there, Y 12.7, C 7.4, B. And then for our interference, I ended up getting 0.49 or 49%. All right, and then last one, number 5, we have it back over here. It's a little scattered, I know. I'm small. Oh, sorry, my hand's in the way. Okay, so we have this here, and so for our allele arrangement, I ended up getting L, R plus, T plus. And then for the gene order, I have R plus T plus L, or just have to have T in the middle. And then to calculate the distance between R and T, I got 9.3 MUs. And then the distance from T to L, I got 13.4 MUs. And then here's my linkage map right here. So R 9.3, T 13.4. And then to calculate the interference, I ended up getting 0.2 or 20%, around that. Like I said before with these numbers, if you're 1 or 2 numbers off, I mean, it's different, you know, some people might get like 19% or something around there. So anyways, I'm really sorry that this was like a really rushed. If I would have explained all of them, it would have been like an hour-long video, and I know you don't want to see me for an hour, so hopefully that works, and good luck.